All right, so this is, I know it doesn't say it's 3F, but it is 3F, change of base rule. 4F, thank you, chapter 4, 4F, change of base rule. So, I know I mentioned it on Friday that, when we use our logarithms, we really want to try to use log base 10 because we can evaluate that on the calculator. And so the thing is most of our calculators cannot do other bases. There are a few fancy ones that can do different bases. Most of them only do base 10 and base E, or natural log. So we can change it around. Now, if you didn't already do your stat box, make sure you've got your stat box at the top of your paper. And here is the change of base rule. So if I have a log of any base, in this case base b of a, I can change it into whatever base I want. And so in this case we have the letter C representing whatever base we choose. And what happens is that what we're taking the log of initially stays in the numerator, and then the base becomes what we're taking the log of, and that goes to the denominator. So log base b of a becomes log base c of a over log base c of b. So we can then change it into any base that we want. Keep in mind that a, b, and c do have to be greater than 0, and that b and c cannot equal 1. Most of the time we're going to use base 10. Like I said, our calculators do base 10, so we'll change these things into base 10 so that we can use our calculator to approximate a value. Another one that we could do is that if I have log base b of a, I could use natural log if I wanted to. So same thing, just that instead of using log base c or log base 10, you could use log base e or natural log, and it will still equal the same. Really, there's no one that's better or worse than the other. I think I tend to use log base 10 more, but there's no real reason for that. And the same thing is true with a and b having to be greater than 0, and b is greater than 1. So we're just going to have 2 quick examples for this one. Any questions? Okay. Now, one thing I do want to say is that you want to push yourself in this section to use the change of base rule to solve this stuff. It will be true that some of them you could solve with other methods or other means, but when you do the assignment for this section, we want you guys to practice using the rule, so make sure you use the rule. So this one says solve correct to 3 significant figures. So we'll use our calculator and we'll have to do a little bit of rounding at the very end here. But it says 4 to the x power equals 213.8. So the first thing we have to do is we have to change this exponential equation into a logarithmic equation. And keep in mind that if this is Benny, base to an exponent equals a number, then I'll have log base 4 of 213.8 equals x. So we've done that before, switching between exponential to logarithmic. So what we're going to do next then is change this into that fraction with our change of base. So I'll have log of 213.8 over the log of 4. Again, if you wanted to use ln, that would work. Keep in mind that these are both base 10, even though you don't have to write that in there. So that's that change of base rule. Just kind of changing it and writing it into whatever base we want, like this fraction. Are there any questions about what happened? So then the next part is, since it does say correct to 3 significant figures, you're going to want to use your calculator to approximate that. So I want to give you guys a second to approximate it on your own, just to make sure you know how to use whatever calculator you do have. It's going to get mine up. we should get that x is about 3.87. If you are not getting that answer, let me know, because it must be how you're plugging it in your calculator, so just be careful with that. And again, do let me know how that works out for you, or if it doesn't work out. All right. Any questions then? So just one more example for today. Slightly different because this says solve for x exactly. So on Friday we talked about what it means to solve exactly. Can anyone remind us what that means? If we want to solve exactly. Oh my goodness. I know there were some people gone Friday, but there were still some people here Friday. So remember that to solve exactly means we'll actually leave log in our answers. We will not get a decimal. We will not go to our calculators or approximate everything. So even though we are going to solve exactly, we'll set this up so that if we needed to, we could use our calculator. So we'll still use base 10 or natural log. Now, we also talked about on Friday that if I see that I've got two of these to the x powers, there should be kind of like a bell going off saying we should use a certain method to help us solve it. Those of you guys that were here on Friday, what was that? Like if you had two of those 3 to the x, what should that make you think that you might have to do to help you solve it? Factor, very good. Now, you don't necessarily need to take this first step. I'm just going to take it to sort of show you. We know that 9 can be written as 3 squared. So this might help you see, if you take that step, what we can factor out of both terms. So again, you might not need that step depending on how comfortable you feel. Now that we've got that, we can see that I can take 3x out of both terms, or 3 to the x. Now when I take it out of this first term, my 8's still there, but so is one of these 3 to the x's, right? Since there's 2x, there's 2 of them, so I took one out, one's still here. And then when I take 3 to the x out of my last term, there's a 1. I'm just going to change this slightly here. Remember, like we talked about on Friday as well, if you are struggling with that factoring piece, you can go back to 3D2 to take a look at that. Now that we have these factors, we can split it up. So I can have 3 to the x equals 0. And take this whole thing, 8 minus 3 to, I'm sorry, not 8 minus, 8 times 3 to the x minus 1 equals 0. So we can split it up into both parts in order to solve it. Now on Friday we talked about 3 to the x equals 0, but there's no x value that could possibly equal 0, so that part's undefined. Then we can go ahead and try to get x by itself over here. So I'm going to start by adding the 1 and dividing by 8. So 3 to the x equals 1/8. So I did two steps at once there. I added 1 and divided by 8. And again, since we're in this change of base section, what we will do is let's change it. So I've got log base 3 of 1/8 equals x. So I'll change this to base 10. For me, when I do change of base, the thing that I struggle with most is remembering like what goes in the numerator and what goes in the denominator. So you guys tell me what goes where. Where does the 1/8 go? Where does the 3 go? Very good. So 1/8 is in the numerator, and then 3 is in the denominator. Since it says solve exactly, we can stop there, but we could use our calculator to approximate an answer if we wanted to. And remember that if you do want to use natural log, it ends up being the same thing. So I'd have the natural log of 1/8 over the natural log of 3. So just kind of keep that in mind that if you see the back of the book, use this natural log and you use a different one, that's really okay as well. Any questions or concerns? Anything you guys are maybe unsure about with this change of base? Like I said, it comes in handy because not all calculators can calculate different bases. All right. So for your stat box, just write that change of base rule so that it's right there on the top of your page. So when you turn back, you can see it right away. So, like I said, P.S. it is in your formula packet, so it's not something you have to memorize. It's still good to have that in your notes right out front. And then here is your practice assignment for 4F.